It's like real wine, so I think you mean that.
Oh, really?
Yeah.
I remember when I went to a church for the first time and had real wine. I didn't know it was real wine. I was like, what is this? It tastes awful. I'll never drink beer. I think beer tastes fine. Nah, sorry, guys. Alright, I guess that was on camera. So maybe you should edit that out.
Whoops.
Alright, here we go. So this is going to be a solution. Number 2, Marty.
I would say, well, you can't really tell if there's water in there because it soaks in. But if it wasn't that much, I'd say
Yeah, so depends. I guess you could just have a lot of dirt and just very little water and just be kind of like a mucky. And that would, I don't know what you would necessarily call that. We're talking like a lot of water and a little bit of dirt in it. So then that would be specifically, a more specific version of heterogeneous, which would be a what? Suspension, because it would be a solid in a liquid. Okay? And this one's probably the hardest.
That be substance or something?
Neither.
compound.
No.
That's a fructose.
It's
Well, it
actually
has
it.
like fat on it, right?
Cream.
It's a
Is that a
suspension.
solid or a liquid?
I would call that a liquid.
I would hope it's liquid.
Yeah, so it's a heterogeneous mixture.
What?
And here's the reason. If you let whole milk sit for a while,
So wait,
great.
you could say that, but even just if you had it sit, yeah, you would see separation. You would see the cream separate from the watery substance. And I wouldn't give you an actual example that I saw of this yesterday, but it's kind of gross, so I won't. Cottage cheese.
Wait, so it would still be called heterogeneous?
What do you mean?
Or like, okay, so.
Whole milk just means like it's not homogenized. So that one's a little bit of a trickier one. So the key thing is there are some heterogeneous mixtures that look like homogeneous, but if you let them settle out, after a period of time, they do settle out. Okay? Blood is actually another example of a heterogeneous mixture,
What?
but you wouldn't know it unless you let it sit.
Oh, blood.
Blood.
Okay.
Yeah. Now, how often do you see blood just sitting there?
Hopefully not a lot.
Yeah. Okay.
Natalie.
We ended there.
Yes.
Okay, we got through ions, correct?
Yeah.
Okay, quick review on ions. What are their names? Okay, be more specific about a cation. Someone?
Positively charged.
Positively
I always want to think
charged.
that because cats suck.
Cats have paws.
Negative.
Yeah, I think the opposite of what you, yeah.
I like that.
They're paws.
Anion is negative.
And what?
Anion.
Okay, so how does it become positive? How does a cation become positive?
By losing electrons.
Losing an electron.
By losing an electron. You're losing a negative thing, leaving you with more positive things, making it positive. Okay, can you gain or lose protons?
No.
Well, you could, but that would be an atomic bomb.
Yeah.
Well, I mean, an explosion similar to that. All right? You can't split an atom very easily. It requires a lot of energy. Okay? So, we're going to talk about monatomic, diatomic, and polyatomic elements. Again, this should be reviewed from physical science. We're not going to spend a ton of time talking about it. Mono means what? One. Now, one element. Does it say one molecule?
No.
Does it say one compound?
No.
No, one element. Okay? There's only a few of these guys that ever exist. Anyone know which ones they are? And why?
Oxygen.
Nope.
Is it? Xe.
Xenon.
Where? Xenon.
Argon.
It's the whole.
And.
Yeah, what is the 8 row called? Anyone know? Starts with N. Starts with an N. What's that? Noble gases. Okay, what is specific or unique about the noble gases, if you remember? They have a full outer energy level, they have a full octet, and so typically they do not what?
Share.
Bond. They typically don't need to bond. However, if you take advanced chemistry, we shatter that and we bond them all the time.
Oh, dang.
Oh, well, that's.
But
If a king farts, it's called bubble gas.
I'm sorry, I enjoy that.
When you get more candy.
I got more. I got candy in there still.
How much money?
Tell me you didn't eat that all already.
I'll spend
She
my
did.
$4.
She ate like 4.
No, I made $4. I made $8, but technically.
Wait, you sold it?
Oh yeah.
It says on the package, not eligible for resale.
That's too bad.
We're not.
It says that?
It might,
Not
after
resale.
one, it's not a.
After one. Okay, here we go. Diatomic. This is where I want to camp a little bit because diatomic elements are very, very, very important. Di meaning what? Two. But are we still one lone element?
No.
Yes, we're still one lone element. There's a difference between a diatomic element and a diatomic molecule. A diatomic element means two of one element. A diatomic molecule could also mean two of the same element, but also could mean two different elements bonded to form a molecule. Okay, so let me give you an example. O2, one element, two of them, diatomic element. HCl. This would be a diatomic molecule. Two things bonded together, but are they the same element? So you cannot call this a diatomic element. This is a diatomic molecule. This is a diatomic element, but it also is a molecule. So we could also call it a what? Diatomic molecule. This would be both. This is only a diatomic molecule. Makes sense? Okay. Now, you should remember this from physical science, I hope. Do you remember the 7-on-7 rule?
Oh,
Yeah.
Okay, it's a quick way to remember what all the diatomic elements are. It will come back to us. Okay, we need to know this because when we get to the writing chemical equations chapter, you have to know them. Because if you just put O2 as O, you're not going to be able to balance the equation very well, are you? Okay, so here they are. And we'll go over this a few times, but if you remember the 7-on-7 rule, you start with the atomic number 7. So nitrogen would be one of the guys that can exist chemically as N2 by itself. Okay? You make the shape of a 7. So if you watch if I were to actually draw, that looks like a what? It looks like a 7. There are 7 of them. 1, 2, 3, 4, 5, 6, 7. So if it starts with the atomic number 7, I got the shape of a 7, there's 7 of them. If it's one of these 7 guys, if it's by itself, it will always be in the diatomic form. You will never see oxygen by itself like this, ever. It will always be O2. And we can get into why that is and why those are the guys that can do it. Well, it just has to do with how they both can share 2 to be stable versus the other guys aren't going to be able to do some of that stuff. Okay? Now, there is one exception. Anyone know what the exception to that is?
Hydrogen.
Hydrogen also is diatomic. So it's a 7-on-7 rule and hydrogen. Those guys are always diatomic if they're by themselves. Okay? Very important for later. Not extremely important for now, but very important for later. Poly. Poly meaning?
3 or more.
3 or more. Okay? Because it's multiple, can multiple be 2? Or is
Yes.
that- yeah. Right?
Multiple means more than one.
Okay? So 3 or more. Elements whose particles are normally composed of groups. Ozone, sulfur, those guys can actually exist in more than 2. Okay, but notice, still one type of element. Everyone see? Still one type of element. Okay, so we're still dealing with polyatomic elements. Alright, molecules. I actually added, no I didn't, I must have gotten rid of it. It should say atoms. I And then in between there, I want covalently. Now I can guess I could probably assume that you forgot what covalently means.
Go down in there.
But what is it between? You're close. You're
It's
almost
two, they share two.
Yes.
between two nonmetals.
Oh, right.
And they share them, yes. Okay? So, we started that flow chart, right?
Yep.
And we had compounds?
Yep.
Okay, I want to add to that. So, we're going to break the compounds up into two things. You can write it a little differently if you want.
It's on the other side of oh.
Yep, so I don't know, yeah, it's gonna be, so matter on the left side, you've got your pure substance, then we drop down to atoms, and the other side would be compounds. I'll get you that later, when you come in, or some other time. Okay? Compounds can be split up into two things, molecule and a formula unit. These guys are covalently bonded. These guys are bonded ionically. And we'll spend much more time doing this when we get to naming. But I want to be very specific that if I say molecule, I cannot use a molecule to refer to something that's ionically bonded. We call that a what? Formula unit. I don't know if we ever gave you that vocab word in physical science. That's probably a new one. Okay. So compound's the big picture. Compound would be anything that's chemically bonded. Okay? More specifically, okay, a molecule would be covalently bonded between nonmetals, and we'll get to that. You guys remember these guys are the nonmetals, these guys are the metals, and the stair step. You guys remember that? Yeah, at least like I'm not sure.
Yes.
We'll get into that again. I tend to get a lot. I tend to go ahead a lot of times just so it's not the first time you see it when we actually talk about it. All right? Okay. So again, distinct groups of atoms bonded together, but it's specifically covalently. So H2O, propane would be molecules because non-metal, 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 non-metal. Yes?
What is the other one?
Formula unit?
Yeah. Yeah, it's two. Metal and metal, is there metal and metal?
That would be metallic bond.
Yeah, is that the three?
Yeah. Yep. We don't deal with metallic bond stuff much. I don't know. Okay, chemical symbols. I'm going to kind of breeze through this because I think you guys are pretty good with this. But as you know, the periodic table up there has a whole bunch of chemical symbols. You don't see the big long words. Thank you, Jesus, for that. Okay? Can be 1, 2, or 3 letters. Most of them are 1 or 2. Once you start getting into those guys, we do naphthalene and all those are. But we won't ever deal with those. Chemical symbols represent a chemical name. Now notice, the first letter always, no matter what, is what?
Capitalized.
Capitalized. I know that's not what that says.
Okay.
Okay, I know that's not what that says. The first one's always capitalized, period. Now, some of them come directly from their name, like C is what?
Copper.
No.
Calcium.
No. Okay, N is what? You guys memorize about 55 elements, so that's coming. Oxygen, sulfur, okay. What about this one?
Potassium.
That doesn't make sense now, does it?
It doesn't matter.
Because there's already a P, which is what?
Phosphorus.
Phosphorus. Okay, so what this is trying to say is simply that there are some guys that don't align with their name, And so they name them a different way, and it's usually by a couple other things, which we'll get to here in a second. Plumbum.
So, what is
Lead.
lead? Because it's slumber.
Okay. All right, if some elements have the same first letter, then we usually go to some other thing. Now, first letter is always capitalized, second letter is always lowercase, and here's the reason why. If you're writing a formula, let me see if I can get one.
CL.
NaCl.
CLL.
LiCl, lithium chloride. If you did capital, all capital, what would that look like?
Well, there is no just capital.
There's no capital L, but
Iodine would be in there.
but what is capital I would be what?
Iodine.
Iodine, okay?
Iodine.
So the way to identify the difference between these guys is whether they're capitalized or not. Okay? Question so far. I know I'm kind of moving fast, but this is pretty straightforward stuff. We need to know, why do we have some capitals? Why is the second always lowercase? It's for simply writing formulas and not being confused. Okay. Okay. So if we've got guys that have multiple, they start with the same letter, and we give the P to phosphorus, but we give the K to potassium. How do we give it K? Is there some reason? There are some reasons. There are colors, there are places, there are heavenly bodies. Latin names, another one, plumbum or lead. PV. Plumbing from your bumming, right?
Hey, you got my gold.
You have to come.
Alright, so you probably have some multiple choice question on your test dealing with this. Okay, colors. Latin word rainbow. Interesting. Yes, there is an element called californium.
Why?
Because the people who find it get to choose the name.
That's not.
And they must have been from California. That or their long lost lovers from California.
Where's
Okay?
that?
What?
Oh, there's 98.
Helium from the Greek god, or Greek word for the sun.
Really?
Yep. Did you know a lot of the sun is made up of helium?
That's why it floats.
Okay, there you go. There's your compounds. I don't know why all of a sudden at the very end here or near the end we've got these compounds, but pure substance consists of two or more elements chemically combined. Does it say anything about needing to be covalent or anything about needing to be ionic?
No.
No, because that's the big broad one. Then we get more specific, we got your molecule and your formula unit. And we'll define formula unit in a far later chapter. Chemical formula. I'm moving through this kind of fast because I can. I don't think it's really pretty straightforward. Chemical formula. Okay, they show two things. They show the identity of the atoms that make them up, and they show how many of them you have. Okay? What's in carbon dioxide?
Carbon and two
Carbon and oxygen, and it tells you that you have how much oxygen?
Two.
And how much carbon? Pretty straightforward. Tanner, you with me?
Yep.
You're not falling asleep, are you? Alright, sit up. That's not sitting up. Back against the wall. Alright, there you go. You'll be alright. You'll make it. Okay, subscripts. You guys know what a subscript is, correct?
Yes, sir.
You guys know what a superscript is?
Yep.
Yes.
Is that the one up high?
Yeah, it's like an exponent.
Oh,
Okay, subscript. Subscript tells you what?
How many of that element?
Alright, well, physical science students haven't seen this, but game changer. Wait, that's not what I want.
There's one in the notes.
Is there?
Yeah.
Okay. There's a subscript. That is not like the other subscripts, yeah? Yeah, so this is going to be a little different, okay? So this subscript tells me I have 3 calcium, 1 phosphorus, 4 oxygen. What does this subscript tell me?
There,
Multiply.
There are 2 of these. That's a polyatomic ion known as phosphate. You'll have to memorize that in chapter 8, along with 8 others, I think. Okay? This tells me I have 2 of this, so essentially 2 PO4s, which means how many oxygens in here do I have? 8 total oxygen that this particular compound has. And how many phosphoruses? So think about it as this. You got those parentheses. What do you normally do if you got a number outside of parentheses in math?
You multiply
Multiply.
it into them.
Okay? Very important. Alright, yeah, I guess I did have one. Okay? If you've got parentheses, that identifies a particular thing known as a polyatomic ion. We'll talk about that much more later. And it tells you how many of that particular ion you have. Which is what I just showed you, so I'm not going to say it again. Ah, this is what's important. This is very important. Should we start with an easy one or a hard one? I'll start easy. Is there one in your notes? Alright, coefficient. Standard size number in front of your formula. So your formula, remember, is how many atoms and how many of them you have in a particular compound. Okay, number that comes in front of a formula. So here's your formula. This would be your what? Coefficient. That coefficient tells you what?
How many is that?
Yeah, how many of that compound you have? So that, I have 5 of those iron oxide compounds. Or formula units, I'll be more specific. Okay? So, what if I asked you how many iron makes up these 5? 10. Now, you either can write all 5 of them out and count them individually, or what's the quicker way to do it? Multiply. So you're essentially distributing just to the iron and oxygen. Very important. So I have 10 iron and how many oxygens? 15. Let's do a more challenging one. What was the one I had up here? Calcium phosphate. That should be a 3. Let's say I've got a coefficient there.
Oh, I love this.
Tricky. Okay, we're going to have to be good at this because when we get to writing equations and balancing those equations, we have to know how to count atoms. Otherwise, we got a problem balancing if we can't count right. Correct? All right. How many calciums do I have?
12.
So 4 times 3 would be 12. I want to know how many atoms you have, and I think that you'll have to do this in your homework. Okay? How many phosphoruses do I have?
8.
You actually have
You have 8. You guys know why?
Yeah.
Because I have 2 of these phosphates, each one has 1, so I've got 2 there, plus 4 of the molecules, each molecule has 2, what would that make it? 8. So essentially you're doing a double distributive property here. You got 2 there, times 4, 8. Okay? These are the trickiest of all of them, so it doesn't get any harder than this.
16.
How many? No, more than 16.
32.
4 times 2. Yep.
8 times 4 is not.
So what's our math give us?
32.
Now, it doesn't matter, right? If you're multiplying, it doesn't matter if you do 4 times 2 times 4, or 2 times 4 times 4, or 4 times 4 times 2, you still get...
Why did you do 4?
Yeah.
Because I was going to tell you, yeah. The point is, you can do 4 times 2, and then times 4, you get 32. You can do 4 times 4, and then times 2, still get 32, right? Doesn't matter the order you multiply, it's going to give you the same thing. Okay, are we following? So I could, if you're still struggling with this, you could write this particular thing out 4 different times and then count them individually, but that's going to take you a little longer, isn't it? Okay? And we'll get some more practice with this here instead. Like now. Right? Okay, so here's what I want you guys, oops. I want you guys, there's really not that many tough ones out here. I want you guys to do this on your own. We'll come together and get you the answers here. Now I want to know each element, how many of them I have. Okay? And you can just abbreviate with a symbol. You don't have to like name them all like Na, sodium, and there are 14 of them. Is this yours, Gage?
Yeah.
This is your folder too.
Yeah.
I think it's my sister's from like, probably
That's smart.
6th grade.
That's smart. I'm glad you don't have self-confidence issues, Gage.
Oh, you see, it's written in front of it.
That says Mac.
It's this cute.
That's awesome. Oh, that sounds like your sister.
Yeah. I don't know what year that's from
Well, it doesn't say anything vulgar or negative, so it can't be chemistry. Not that she would ever say anything vulgar. It was probably a love-hate relationship for her in chemistry. And I'll give you a couple harder ones here in a little bit. Alright, I realize this probably seems pretty easy, and it's not. But we're laying a foundation, and I'll say this probably 400 times this whole year. Chemistry builds on itself. It's really a whole bunch of really easy things that just keep building. So you get that behind one day, it becomes very hard. Okay? So we need to make sure we stay on top of things. We done? Why did I throw that last one up there? I don't know.
End on an easy one.
What?
End on an easy
And
one.
get our confidence back up.
Yeah.
I feel like you guys will do just fine on this, but maybe not. We'll see. Shelby, you done? No, keep working then. Sorry.
Isn't there like for the 5th one, isn't there supposed to be like in number of order, like 11, 12, 22 or something like that?
No. It's never in order by how many you have. It all has to do with its oxidation number.
Oh, that was the number.
Like cation, anion, or if it's covalent, it's least electronegative, most electronegative.
It just needs to come back.
It's
Yeah.
usually-
It's been 2 years for me. I'm
I'm
not lost, but it's all balanced.
But it's pretty easy. It's coming back to you, right?
Yeah.
Really?
This isn't hard.
Yeah.
It.
I have a feeling, Brevin, I just have a feeling that, yeah, this stuff that will be review, you may not remember it right away, but as soon as we talk about it, it'll come back. At least I was.
Like vaguely sounded familiar. I don't think so. We didn't do like any chemical stuff last year.
You had, I think you had a whole chapter where you had to memorize some elements.
I think we just basically skipped that. Like, you'll talk about this you talked about this last year. You'll talk about it next year. Let's skip it.
That's
Basically.
what he should do.
Who?
Safford, he has like a chapter that's chemistry related, which you get it as a physical science student, you get it as a chemistry student. I don't think you need to go over it. To me, it would just a way to.
2011, what was she doing?
I'll be your partner.
Alright,
You can cut them.
Yeah.
Shelby, can you tell me how many of each of these we have?
Yep.
How many sodium, Shelby? How many sulfur? How many oxygen? Pretty easy, right? Tanner, how many magnesiums?
1,
How many nitrogens?
2,
How many oxygens?
3, 5.
There were 2 of these.
6.
Okay? Number outside of parentheses, treat like a distributed property. 6, 2. Quinlan, calcium, how many? Bromine? Yep. Brevin. You be the fun one.
Ba 2. Nitrogen 4. O 12.
Very good. And next 2 are pretty easy. 12, 22, 11.
What's the last one?
Gage, I'm not sure you can do this last one. You're gonna have to really think. Okay. You want me to give you one hard one, or you?
Yeah.
Do it really,
Yeah.
really hard. Like,
Maybe not really, really hard. But
like one that you can't even do.
Not really, really hard.
No,
Just
It doesn't exist, Trinity.
Start making
Oh,
stuff up,
okay.
like squared 7.
Square and 7.
Do you like the subscript?
I'm gonna write it incorrectly just so it's harder.
Why?
What?
Because there's
Trinity, that you just
What?
asked for it.
You
There's only one way I can write a lot of these
You
things.
can't write
Yeah.
it wrong. It's like, what?
What like
Fine, I won't
bonds?
write it wrong.
No, like the bonds will be wrong, right? Is that what you're saying?
Yeah, like there's always a specific way you write these guys.
Yeah, it's just fine. Just
Oh,
mess
yeah.
up.
I thought you were saying. Okay.
Because like this has an oxidation number of 1, and so then I could only have like 1 aluminum.
Yeah.
But I was gonna put a 4 here just because it makes it harder.
I'm
It
saying.
have to be a 1, but
No, yeah, do that. I thought you were gonna like write it all.
I'm saying the coefficient should be its own math problem.
What?
Like 2.
Is that
I
okay?
think I
That's
have
an
to do that
11.
later on
Yeah,
homework.
11 is good.
I understand concept.
try this one. This will be a ticket out the door. How about that?
Oh, come on.
You weren't gonna do it.
You're right.
What the heck? It was just 18, literally like a second ago. Did it just jump like that?
Can we just go? Because I need to go get my seat history.
Yeah, that's true. She doesn't let us go to the bathroom. Class. Go ever.
I'll do it.
Show me tomorrow. Your homework. The homework that was
There you go,
due.
there you go, Amber. Good stuff. That's probably wrong.
This was mine.
I'm so sorry.
99 hydrogen.
Okay, answer.
It should not be about you. It's about how God gave you the ability.
God is so good.
What is more?
He is so great. Let's just say that
Okay,
he
you
was
find
really
that
good
person.
to you. And I will find that person. I will bring it tomorrow.
Okay.
I'm pretty sure that's not the Bible verse.
That's not. And if it is, it's only by freaking
Pretty sure that's not what the Bible says. Well,
Where's
not
that?
I'll tell you wrong.
The Old Testament.
Don't bring the Quran, please.
I'm not.
The Old Testament.
Oh, it's the
Oh, what is the hope?
7. What's your name in? Alright?
History is my favorite class.
What happened, Tyler? It's not.
It actually was, I mean, I only got right. I literally.
For no reason.
No, she had her phone out on us, and she told her to put it away 4 times a day. That's how
But then she had it, well, she said she had her second.
Ireland has its own problem.
That was her
Wait.
fault.
I'm glad that a student can realize that there's a difference. Teacher fault. Student.
Oh, well, the thing is, she put it in her backpack. She's like, it is a way. She's like, you put it in your bag. And she's like, it is a way. It was on her desk and stuff. So she wasn't on it. But she's
But she said it like that.
yeah, she's like, it is a way, I'm not on it. And I was like, I did not talk back and forth.
Shoot, don't have my book.
Oh
I'm
wait.
like, well, no, she's not gonna like you if you talk to her.
So confused as to what I just saw.
What?
I'm so confused as to what I just saw. I saw Tanner like hopping out of here and then all of a sudden he was like, I was like,
Tanner Curran's not injured, he took the Christmas run.
oh,
Tanner is gonna show us tomorrow how in the Bible it says you shall not drink. So there's a Bible verse that says specifically it is wrong to
Did I get
drink.
drunk with wine?
That's different.
I know.
But then it,
That means you can get drunk with anything.
he might choose the
That's why I
passage
choose vodka.
specifically to the priest. He might-
Stop. I was gonna say, this is
You're fine as whiskey.
If you only drink vodka,
So I said on camera, I need to stop that.
yeah, you probably.
Don't get drunk.